Hello everyone, good afternoon.
Hi.
Good afternoon, sir.
Good afternoon.
About 9, right?
Good afternoon.
Yes, sir. Okay.
Hello, Ishan sir.
Yes.
So this is Rishikesh. I have one question. I mean, yesterday there was a practice session, but it was not published in our Google Calendar. So why is that?
It's not the practice session, it's some
Yes,
special
special session. But it would be good if you like either you record or publish, because even it is useful for everyone like us, right?
Yeah, we will have such
They were
multiple
notified
sessions.
already that Google Meets are not going to be.
Yeah, the purpose of them is that it won't be recorded because that's.
But then at least can you publish it? I mean, why actually I'm like saying that it should be recorded is we are working professionals, and sometimes we actually do not get a specific time to attend. So usually what we do is we usually listen to all these sessions during night or after our working hours. So it will be really helpful for us to if we can have everything recorded and published.
No,
I second
these sessions have some different purpose, and it's not like we have only that one session. We will be having multiple session, and date and times will keep on varying. So there will be definitely one slot where you will be free to attend or something. And if you are not, then also in these sessions you can get your doubts clarified. It's nothing like that. But those sessions have some different motives for which we are conducting that. And yeah, it won't be recorded as mentioned earlier. Yeah.
I mean, are these the revision sessions like we had for?
No, it's not like a revision session. It's like there are a few students who are posting week 1 to 4 doubts under discourse and discussion forum, right? So it means even if we are in week 9, there are some students who couldn't get to ask their doubts or couldn't ask it in these sessions. So those special sessions are basically for them, so that they can come and interact with us and get that solved. It's on the previous weeks.
Even I need those sessions, so it would be helpful if you could, like, if you get some notification beforehand.
Yeah,
I
we
would
get
like
those notification on Telegram group one day before.
Telegram.
Telegram group. Yeah, we have made announcement twice regarding that as well.
Oh, I did not know about that Telegram.
No,
we
I
have,
actually joined a Telegram, but I did not get any notice. Or have I joined the wrong group?
No, in Telegram group, I have posted on Friday night that I will be taking that session on Saturday evening.
I may need to check.
Yeah.
Otherwise,
someone has posted the link to the channel as well.
Okay.
Telegram is called now.
Yeah, we will have one on Wednesday as well, and we are planning to get one tomorrow as well. So it's not like it's like you can attend any of these. It's not you have to attend them all, and so attendance is not mandatory for those sessions.
Sir, but if it is recorded, it will be, because yesterday's session
Excuse
was
me,
good.
sir.
If it is recorded, then
Sir,
you're great.
Sir, I have a doubt, sir. Can I ask?
In which week 9?
Yes, sir.
Yeah, if you come into that as well. Yeah.
Hello.
Yes.
Hi. Was there any session on Friday or it was cancelled?
Friday sessions are cancelled. We have made announcement regarding it as well. Right? I think all of you may have received it. That replacing that Friday session, we will be conducting some special sessions.
Telegram ones.
Yeah, Telegram.
Okay.
And there won't be only one session. There will be multiple. Like one could be
Now
tomorrow
there
as
will
well.
be like 2 sessions on the
Two
calendar.
official sessions like this, the recorded ones, and 2 to 3 those special ones.
Okay. Thank you.
Yeah.
I mean, I still feel it will be really great help if we can record. But I mean, of course, you can check with your faculties and
we will have to.
but
because the recording purposes there are just those sessions have a bit different mode. There are some there are few students who still hesitate to ask in the live session. So if the sessions are not recorded, we feel that they might be more comfortable to come and ask. So that's also a thing.
Yes, sir. 9.1, sir. Question number 10
Okay.
and 9 and 10.
Okay, and yeah, one more thing regarding this course, where one student is, I think, has posted previous term solutions PDF of graded assignment we get, which is against our community rules. So he is facing some disciplinary action. So you all are requested to not to do such things on this course and discussion forums. Okay, yeah. Question number
9 and 10.
Sure, also 11 if you can.
Question number 9, insurance company. Independent rate and person. Okay. Okay, so as per question, the salesman goes to 3 clients, right?
Yes, sir.
To sell, and the probability of them buying is 0.1, each of them buying, right? Okay, and one more thing given to you is that all of the 3 clients are making their decision independently. There is no dependence. See, like if client 1 rejected, it won't affect the decision of client 2 and client 3, right?
Yes, sir.
This much information is given to you. So I can define 3 events, right? Even that, okay, we have to find the probability that x equals 0 first of all, right?
Yes, sir.
X equal to 0 means none of the client.
None of the client buy.
Okay, none, right? So I can define 3 events that client 1 doesn't buy it. Okay. Okay. Similarly, E2 could be that client 2 didn't buy it, and similarly E3, right?
Yes, sir.
So X will take the value if all of these 3 events happen together,
Yes, sir.
which is same as E1 intersection E2 intersection E3. And the independence thing is also given to you, that all of these 3 clients are making their decision independently, right? So by using the property of independence, we can open this intersection as this, right? Using multiplication rule.
Yes, sir.
And you know, if the probability of buying the policy is 0.10, so probability of not buying is
0.9.
0.9, right? So client 1 doesn't buy, it's 0.9, same for client 2, and same for client 3. Right. So random variable is just, it's like you have to solve the question of week 7 and 8, but the random variable tells you like which events you have to find the probability for. There's nothing major difference between them. Is this clear?
Yes, sir.
Question number 10.
Sir,
Yeah.
is it done?
Yeah, that's what we have to find, right? X equals 0.
Okay, sir.
Okay. Moving on to question number 10. Okay. It is the 3 posts to deliver in 3 adjacent house. Okay. Okay. So see, there are 3 adjacent houses, right? Let's label them as A, B, and C.
Sir, in
Yeah.
the previous question, it is mentioned that defined as the number of sales he made in a day.
Yeah.
So what if he made only one sale, one number of sale, only one?
Only one. In
Yes,
that
sir.
case, you will have to make the
Sir, we are taking You have taken all 3 sales he is doing simultaneously.
Yeah. In a day, he is doing 3 sales.
But in a day, he's hoping to sell. Once he makes a sale, he stops. What if he makes a sale in a first case, first time
Yeah.
only?
Yeah. For
Then,
that,
then
you
he
will
will
have,
stop.
yeah, for X, in that case, X will be 1, right? He made 1 sale.
Yes, sir.
So you will have to make cases like first client buys the policy, right? Even complement will be that event.
Yes, sir.
Next thing possible is first client didn't buy it, but second buy it.
Yes, sir.
And third case will be first didn't buy it, second didn't buy it, and third did buy it. And also these 3 events are disjoint, so I can simply add the probabilities.
So both process will going to give the same answer.
No, it's for probability X equals 1. It's for X equals 0.
Okay.
X equals 0 means none of them buys. X equal to 1 means if the first client buys, then he
He will
won't go
stop.
to second and third. Yeah,
Yes.
it's not going to.
Yes, sir.
Similarly like that. So X here can take only 2 possible values, 0 and 1. None other than that.
Okay.
If you
Thank you,
compute
sir.
it will see. Okay. Moving on to question number 10. Okay. Suppose we have 3 houses, right?
Yes.
A, B, and C. And the postman has 3 letters, 1 for house A, for B, and 1 for C, right? Okay. Now suppose if I have delivered 2 correct, right? Suppose I have given A to A and delivered B to the correct ones, right?
Yes, sir.
Then C cannot be wrong because it has only one option.
Yeah.
Or another, if I make A correct, right, and C correct, then also B has no other way. B will definitely be correct if 2 of my are correct. So there is no way X will take the value 2, because if 2 houses are delivered correctly, third will definitely be delivered correctly. Right? So only possible value X can take is 0, 1, and 3. It can take the value 0, value 2. Because
2 correct.
if he is making 2 correct, right?
Yes.
A and B, then C will definitely be correct because
Yes, sir.
it's the only one left. If I am making 2 correct A and C, then also B will definitely be correct because it has only one option to go in.
Then it is taking X is equal to 2 values.
No, it's taking X equal to 3. I got all of them 3 correct, right?
Okay.
There is no way I
Okay,
can
sir.
get only 2 correct.
Okay, sir. Got it.
So it can take the value 2. Yeah.
And question number 11. I just able to find the number of ways 2025.
Yeah.
If I want to find the probability, then what should be the sample space?
Sample space is, see, you have 10 boys and 10 girls, right?
Yes.
In total, you have 20 students.
Hmm.
And you are randomly choosing 4 of them. So sample space will consist
girls.
of 20
Okay.
elements.
And
That's
in
total.
upper part 10C2 into 10C2.
Yeah, that's your favorable ones.
10C2 into 10C2.
Sir, can you also explain question number 4?
In the same.
Yes, sir.
Yes, sir. I have also the problem.
Sir,
Common note. Yes.
the last question, 11th one, how was the answer 2025? I don't know, but I got the answer to be 45.
10C2 times 10C2. 2 boys and 2 girls. That's 45 squared.
Okay, so you don't need to divide it by 20C4, is it?
No, we are not asking the probability. We are asking the cardinality of.
Okay, sir.
Okay, yeah. For the question number 4, how many outcomes will result in X equals 19? Okay. Do you know how many face cards we have in deck of 52 cards?
12.
Sir.
12.
Okay.
12.
So I need to get the score of 19, right?
Yes.
The only way we can get is
Either
either
we
I get 10
10
point,
and 9.
10 points and 9 points, right? That's the only way. There is no,
Yes.
I cannot get 11 8 or 12 7 something. Only 10 9 is the only possibility, right? So for 9 points, I have 4 possibilities that I get a 9 card of diamond
9
club or something, right? Spade and 9 of
Yes.
hearts. Now for 10 points, I have 16 possibility. One is I got the king. Within king, I have 4 possibility, right?
Yes.
Within queen also, I have 4 possibilities. And within jack also, I have 4. And if I get a card number 10, then also I will 4 possibilities, right?
Yes, sir.
So in total, I have 16 ways to get the 10 point and 4 ways to get the 9 point. So, yeah. So in general, I need any one of these 16 cards, right? And any one of these 4 cards.
16C1 into 9C.
4 0.
Four.
That's
Sir, I
sufficient.
just want to ask a simple question in this.
Yeah.
If first comes 9 and then comes 10, then that sum will be 19.
Yeah.
But there will also be possibility then first it comes 10 and then comes 9.
Yeah, but we are not interested in the order of something. It doesn't matter in what way I'm getting. I'm just drawing 2 cards simultaneously. I'm just picking up the 2 cards at the same time. It doesn't matter if I get 10 first or 9 first. We are choosing.
So what should be the question if this process has to be applied?
This processor to be, in that case, it would be like you have some, suppose 2 places, and you have to arrange the 2 cards such that their points weightage is 19. Then in that case, it's possible that you get a 10 pointer here, 9 here, or 9 pointer here, 10 pointer here. That would be arrangement question.
And the cardinality will be double.
Sir, if we
Yeah.
are asking about the probability, then we will consider this case.
No. Even in probability, what we do is we take 4C1 times 16C1, right? And total number of ways are I am choosing any 2 cards of the 52. Do like that.
Okay, sir.
So we are doing the selection or choosing question. But if the question is of arrangement, that case will be different. Okay. If you have to arrange 2 cards in the 2 places such that their points weigh 19 points, in that case it matters whether I'm getting 10 at first or 9.
So can you repeat this line again? What?
If I have to arrange 2 cards at these 2 places such that their sum of points weigh 19, in that case it matters whether I put 10 at the first place or 9 at the first place.
Okay.
But if I am choosing only 2 cards, it doesn't matter which one I choose first and next, right?
Sir, in question it is also written that because the 2 cards has been taken out simultaneously. If it is written that the card is taken out one by one, then also 16 into
1 by
4.
1, then it would be mentioned whether we are doing without replacement, with replacement. Such things will be mentioned.
Then the question will be different.
Yeah, that's assumed to be without replacement. We are drawing it together.
Yes. Okay.
Sir, question 9.3, question number 4.
3, question number.
Sir, my doubt is how x is a discrete variable, sir.
Okay. You got this correct? Like x number of values x can
Yes,
take
sir.
is
Yes,
21.
sir. I got that correct.
Okay.
So, sir, I have doubt in this question. How come x equals to 21?
Okay, we come to that.
Because the values are not always integers, sir, of hypotenuse.
It doesn't matter if it's continuous means we can take infinitely many values
between 2 values.
Yeah. Okay. Let's first see how we got the 21, right? So either I can get, these are the possible outcomes, right? There are 36 possible outcomes when we roll 2 dice, right?
Yes, sir. And 15 outcomes are double.
Something like that. 3. Okay, similarly, we will have for 4, 5, and 6, right? Okay, if you notice over here, of all these 36, right? If I take the first element, it means my base is 1 and height is 1, right?
Yes, sir.
So my hypotenuse will be under root 1 square plus 1 square, which is square root of 2, right?
Yes, sir.
If I take this case, then in that case, it would be root 5, right?
Yes.
But here also, if I take this, again, it would be root 5.
Yes.
So you will see that there are only 21 values.
Yes, sir.
21 values means this upper triangle of matrix. Only these 21 values will give me the unique hypotenuse length, right? This 1, 3 will give me the same value as 3, 1.
Yes, sir.
It will give me the same. So out of these 36, only 21 will give me the unique values.
Okay, sir.
So X can
Got
take
it, sir. Thank
21.
you.
Okay, now consider any two values. Like this case was giving me root 2, this is giving me root 5, right?
Yes, sir.
Root 2 is somewhat 1.414 and root 5 is, I think, something 2 point something, right? So see, either I can take this value or this value. I couldn't get any other value in between them. 1.8 to 1.876. So this is not continuous. Continuous is
If you
I
are
can
getting
take,
values in between, then it is continuous.
yeah, continuous mean I can get all the values within between any two values.
Okay. Okay, sir. Thank you, sir.
Okay. And also X equals to, for continuous, we can have infinite number of values that you can't even count, right? So if you are saying that X can take only 21 values, then there is no way it can be continuous. Okay. Yeah.
Okay, sir.
9.2 question number 3.
Okay, 9.2 question number 3. Okay. There are 10. A ball is randomly put back. Okay.
Sir, I find the cardinality. Again, the problem, if I want to find the probability, then what should be the case?
Okay, 1 minute. Okay, so ball is drawn randomly. This case, this line specifies that we are doing with replacement, right? We are drawing, noting the color and putting it bets. So
Yes, sir.
for second row again, I have 50.
With the replacement.
Yeah. So first we have to find that X takes the value 1, right? It will take the value 1 when both balls have same color.
Hmm.
Okay, so if my both the balls are red or blue, right? There is no other way I can get the value 1.
Yes, yes.
So in total, I have 10 red balls and 5 blue balls. So for the first, any of the 10 red balls can come.
Yes.
And again, for the second, any of the
10.
10 balls. Or, right? Or I got both the blues. For blues, any of the 5, any of the 5. So that's 100 plus 25, 125.
Yes.
Possible. And if you have to find the probability, then it would be like 125 are your favorable, right? You have to find total. In total ways, any of the 15 balls can come at the first outcome. And then the second outcome, again, any of the 15 balls can come.
15 into 15.
Yes, the probability will be favorable upon total.
Sir, why not 15C2?
15C2 because we are doing with replacement. We are not doing without replacement. When we do without replacement, then we do 15C2.
Okay. Okay, thank you.
Yeah.
Question number 2.
In the same?
Yeah. So here, why the first value is not correct? Can you please explain?
This one.
Yeah.
Okay. The shopkeeper is interested in knowing the number of X to the number of. Okay, X is the number of customers entering the shop, right?
Yes.
So now customers can't be in
Action.
decimals, fractions. You cannot say it's 0.1, 0.2 or something. Give me a minute. So number of, it can take only discrete natural values, right?
Okay.
It cannot have any other possibilities. And Deepak Saroj, you shouldn't share the unofficial links over here in Telegram when someone asks for the official ones. Note of this.
Okay, sir, your screen not visible, sir.
Yeah, I'm just making a note of something. Yeah, is it visible now?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So your number of customers can't be in the, like it cannot take all the values in this interval, right? It can either take the value 0, 1, 2, so on, right?
Yeah.
That's why the best option is this, not this.
Oh, okay. So that means it includes even the fractional number also. First one.
Yeah, first one includes, it includes all the values in this interval 0 to infinity.
Oh, okay. Got it. Thank you.
Question number 4.
Next one is the information source generated. Okay. Let's explore. Hold. Okay, so probability that X will take the value 3, it's only when we got the alphabet C and D, right?
So it can also be the case when AB will be the code. Suppose it can be 0, 1, 0.
1, 0. Okay, I think we will change the statement for it and mention that only one alphabet code is allowed, something like that.
So because when I'm trying to solve it, comes 1 by 2.
Yeah, someone has also mentioned that this course is. Yeah, we will edit the question statement.
So
Okay.
how to approach this problem, sir?
How? Okay, so it says that the length of the binary symbol should be 3, right? That's what your random variable X denotes.
Okay.
So X equals 3 means when I get either C or D. So the probability of getting C is 1 by 8, and for D also it's 1 by 8.
Okay.
1 by 8 plus 1 by 8, it's 1 by 4.
Okay. So they say the length is the 3 digits. That's what they mean?
Yeah, we will mention that the code is of only one alphabet, something like that. We'll do. Yeah.
No, I couldn't understand what they mean by the length of the code. The length, that means it's a triple digit. Is it so? Or
The length of the code, here it's mentioned that is the number of binary symbols, 0 and 1. So number of zeros and ones.
the number of zeros and ones. Okay. Okay. Thank you.
Sir, practice assignment 9, question number 6 and 7.
This assignment, again, 6 and 7 will be same for everyone. I think. Okay, this one, right?
Yes, sir. I am not able to think on this question, sir. How will you approach this question?
Okay, first you have to find a total number of ways in which he can play his chances, right?
Yes, sir.
Let me share the whiteboard. See, I think one first, okay, I got only 5 chances, right?
Yes, sir.
There are ways that first case could be I get out in the first chance only. right? Second case is I get out in the second chance, right? I get out in the third chance, fourth chance, or I could get out in the fifth chance, or I could get, I remain not out, right?
Yes.
These are the all possibilities. So in how many ways you can get out in the first chance? If I get 0 in the first, right? Only possible scores I can make is 0, 2, 4, 6, and 8, right? So I will be out in the first chance if I get 0 in my first try, right? So there is only one way that I get 0. There is no, if I get any other number, I will remain not out after the first chance, right? Now to get out in the second chance.
Sir, how is it one way, sir? I'm not getting it.
One way is because I will be out in first chance only if I get 0.
Okay, sir.
So there is only one way I can get 0. Right?
And what is the probability of that thing? It is 1.
No, we are first computing the total number of ways I can play.
Okay, sir.
Total number of ways one can play his innings, right? Another possibility is we can get out in the second chance, right? So in the first chance, I should get any of these phone numbers. So there are 4 ways. And in the second chance, I should get 0, which I can get only in one way, right? So there are 4 ways in which I can get out in the second chance. Is this clear?
Yes, sir.
Okay. And in how many ways I can get out in the third chance? I should get any of these phone number in the first 2 chances, right?
Yes.
And get
4
0
for
in the
second
last.
one.
Similarly, it would be 4 cube, 4, 4, 5, right?
Yes, sir.
So total number of ways is adding all this, right? And your favorable base, your favorable are that he remains not out. So he remains not out is only this 4 to the power 5 base, right? So probability that he remains not out is all this.
Then what is the use of here in the question? It is given that assume there is an equal probability of opening for each phase.
Oh, okay. By that, okay. If suppose there is not equal probability, right?
Yes.
Then the probability that
no,
I
sir,
get,
I am getting that, but why this thing is given here? I'm not getting it.
it is to tell you that each getting any of these numbers has the same probability. So if there are total 5 possibilities, so getting 0, it's 1 by 5. Getting 2, it's 1 by 5, 1 by 5, 1 by 5, and 1 by 5.
But you haven't used anything that here.
Here it's same for everything, right? That's why we can simply divide it like that. Counting the favorable. Okay, when we compute probability like favorable upon total outcomes, then each of the outcome has the same probability. If each of the outcome has different probability, we cannot compute probability like that.
1 by 5 will be cancelled out from.
Yeah, from each of these.
Yes, sir. Okay, sir.
Okay. Okay. Anything else? Anyone?
So 9.5 first question, sir.
9.5 last question also.
9.1, right?
9.5, sir.
9.5.
First question.
Yes, sir.
Okay, there are 3 red and 7 blue balls. Okay. With replacement we are doing, right? XP the number of red balls in 3 draws. Okay. There are 3 red, 7 blue. see, so you have 3 red balls and 7 blue balls, right? In total. And your X denote the number of red balls in 3 draws. So your possible values that X can take is either I get 0 red balls, 1 red ball, 2 red balls, or all 3 red balls, right? These are the possible values my X can take.
Yeah, up to this I could get it, sir.
Now you have to find the probability that I got 0 red balls. And I am doing with replacement, right?
With replacement, yes.
So the probability that I get a red ball, or you can say blue ball in the first draw, it's 7 by 10, right? Because 7 balls are blue out of total 10.
Yeah.
In the next draw, again, I should get the blue ball. And again, in the third draw, I should get the blue ball.
Okay.
Okay. So that would be a probability that X takes the value 0.
Okay.
Next is X equals 1. So in total, you have 3 places, right?
Okay.
I should get a red ball in any of these 3 places. So I can choose
Yes,
any one place in 3C one ways.
Yes.
In that one place, I should get the red ball. And in remaining 2 places, I should get the blue ball. Another way to think it like that. Okay.
I did 3C1 into 7C2.
No, not why 7C2.
I thought because if you're choosing one red, the
No,
other
not one red. I am choosing one place at which I
one
will get
place.
the red.
Okay.
Okay. Another way to think it is like I got the red at the first, right? And blue at the remaining 2.
Okay.
I got the red at the second and blue at the remaining 2. And red at the third place. These are the only possibility, right?
Yes, this is for one red happening.
Yeah. So 100 I could get in 3 by 10 ways.
Yeah.
7 by 10, 7 by 10.
Okay.
Sir, sorry to interrupt.
Yeah.
But why does it matter where we get this red, sir? It can be anywhere, right?
Yeah, it could be anywhere, but it matters whether I am drawing in the first draw, second draw, third draw. Right?
So is
3
it like
balls
a
are
permutation here, or what is happening here? Why are we?
yeah, permutation. Because 3 balls are drawn randomly one by one with replacement. So it matters whether I get red at the first or blue at the first.
So order is important here.
Yeah, order is important over here.
Okay, thank you, sir.
But if I am drawing simultaneously, then it doesn't matter. If 3 balls are drawn simultaneously.
Yes, I thought we are drawing it simultaneously.
No. If it's mentioned that we are drawing one by one.
One by one. Okay.
With replacement. So order does matter over here. So yeah, either you can do it like that, make cases, or easiest way is to fix one place for the red, which can be done in 3C1 ways.
Okay.
And then getting red at that selected place is 3 by 10 and blue remaining 2, right?
Okay.
Even if you solve it, it would be same, right? 3 times this and it's 3 times this. It's the same.
And similarly, we have to do for X equals 2, X equals 3.
Yeah, that's the same.
And add all these.
No, yeah, not add. You have to check in the graph, right? For X equal
Graph.
to 0.
Okay, yes. I 0, 1, 2, they have given. Yes.
0, 3, right?
Yes. Okay, thank you.
Sir, can we do the third question?
In the same activity.
Yes, sir, question number 3.
Okay, and where coin is tossed thrice. Okay, and the distribution of here also see, and we are tossing the coin thrice, so it does matter whether I get head at the first, second, or third. Right? So here also order do matter. The distribution of number of tails is given like this. The same toss. Okay. So for such questions, either take the probability at 0 or at the maximum value, which is 3, right? Only take these two or any of these two, that would work for you. Okay. See, x can take the value 0, 1, 2, and 3, right? To
Yes,
solve
sir.
such questions, focus only on this 0 or at the maximum value. Focus only on any one of it. Okay. Suppose I am focusing on x equals 3. Right? I am given that probability x equals 3 is 0.343, right? In the graph, it's given that x equals 3 with probability 0.343, right?
Yes.
So x equals to 3 means I got all the 3 tails. Right?
Yes.
If, let's say, probability of getting tails is p, right? So getting tails as all the 3 position, the probability would be p times p times p, and it is given to us as 0.343. So p cube equals 0.343. So p equals, I think it should be, okay, it should be 0.7. So I got the probability of tails as 0.7. So probability of heads will be 0.3. Right? That's what the question is, right?
But sir, coin is unfair, right?
Yeah, unfair. That's why the probability I have assumed as p. If it's fair, I have said 0.5.
No, but in that case, if it's unfair, then if we have a probability of tails is 0.7, how come the probability of head will be 0.3? It can be 0.1 as well, right? Because it's unfair.
No. Total probability is always 1. Probability of complete sample space is 1.
Like even if it is unfair or biased stuff.
Anything, total probability should be 1. That's the axiom of probability, right? So if this value is 0.7, then this will definitely be 1 minus 0.7.
Oh, okay. I thought this axiom is true only when it is a fair
no,
fair
these
stuff
axiom are true
unbiased.
In every condition you can even imagine, each and every case. Okay.
Okay.
If you want to look at that, we can do that. Okay. Suppose now I'm taking x equals 0. Probability x equals 0, it's given to me as 0.027, right? X equals 0 means I got no tails. No tails means I got all of them as heads.
Right.
Let's say probability of heads
0.3.
is p.
0.3.
So again, it's
okay.
p cube.
Okay, got it, sir. Got it, yeah.
So in such questions, always focus only on 0 or the maximum value. No in between value, which will make it complicated.
Yes, sir. Thank you.
Okay. This one is clear, right?
Yes, sir.
Yes, sir.
Okay. Anything
Sir,
else?
I have a doubt.
Tutorial 2.
In this question, how the word unfair die has changed the answer?
Because if die is fair, then it would be 0.5 for head and 0.5 for tails. Right? It couldn't be any other value. The distribution of number of same term.
Okay, sir. Thank you.
Okay, next. Someone was saying tutorial.
Tutorial 2, sir. Can you explain one more time? I didn't understand that.
Tutorial 2. What is it? Find the value of alpha, comma p. Okay. It's equal to alpha p raised to the power x and x takes value 0, 1, 2, 3. Okay. So your probability mass function is given as alpha times p raised to the power x, right?
Yeah.
And x can take the value
X
0.
can take 0, 1, 2, etc.
So if you remember first case, like first property of PMF, that probability should be greater than equal to 0 for all x.
Yeah.
So if you plug in over here, alpha times p raised to the power x should be greater than equal to 0. Now, product of two numbers would be greater than or equal to 0 when both of them are positive or negative, right?
Yeah.
If my first case is, if my alpha is greater than equal to 0 and p is greater than equal to 0, right?
Yeah.
Or my alpha is negative and p is also negative, right? But what happens is, if I take x equals 2, right? So
Yeah.
alpha times p, this would be negative, but it would become negative squared, so positive.
Square, yeah. Positive it will become.
X equals 2 if I do, right?
Yeah.
So in that case, the product will be negative. So my second
Okay.
case is violated.
Okay.
Okay, this is the only case now I have, right? Second property of PMF is all of them should add to 1.
Total. Yeah.
Right? So if I
Yeah.
plug in the value, it would be alpha plus alpha p plus alpha p square, so on up to infinity equals 1, right?
Yeah.
If you have gone through the tutorial of sum of infinite series, it would be alpha upon 1 minus p.
So I didn't get this.
Okay. If we have to find the sum of infinite GP, you know the GP, because your common difference is of p. We are multiplying by p. We are again multiplying by p.
Yeah.
So you see the common ratio is p, right?
Okay.
And it's going till infinite. So the sum of this series will be first term, right? First term is alpha divided by 1 minus the ratio. Ratio is p.
Okay.
And this is equal to 1 given to us, right? So this implies alpha equals 1 minus p, or one can say that the alpha plus p should be 1. Now if we come back to our first case over here, if I plug in alpha equals 0, then my this product will always be 0.
0, yeah.
Then my all of these values will be 0. My sum can never be 1.
Yeah.
So alpha cannot be 0. So alpha should be greater than 0. P should be greater than equal to 0. And their sum should be 1. These three conditions should satisfy for this to be a valid PMF. Okay. That's what the video is about.
Okay, sir. Thank you so much.
Okay. Anyone, anything else?
Sir.
Yeah.
When will be the discrete random variable function graph, not a step function?
Then CDF function, cumulative distribution function, right?
Yes, sir.
It would always be a step function for discrete.
Sir, but in here the option is wrong. It will be all no, sir. Okay, sir. Okay.
It's a property of CDF of discrete random variable. It would be a step function always.
Okay.
Okay. Anyone, anything else?
9.3.
9.3. Okay. Yeah, which question? Hello.
Yeah.
Yeah. Which question in 9.3?
So question number 2.
Question number 2.
Yeah. The last option, how is it correct? Because 0, 5.
Yeah, if it could be like we didn't even break it. Like we have one part of 10 centimeter complete and one part of 0 centimeter.
Okay.
Okay, so the smaller could be the 0. Or it's possible that I break it 9.99 centimeter. The smaller is a 0.01. So it could take all the values in between 0 and 5. As soon as it exceeds the 5, it would become the larger part. It won't remain the smaller one.
Okay. Okay.
That's why this is true.
Okay. Thank you.
Okay. Anyone, anything else?
I'm sorry, I just joined. I have few doubts, 2 to 3 questions. Can I?
Tutorial questions, yeah.
Not one tutorial question and rest 3 questions in AQ. I don't know whether you discussed or not.
Tutorial 1. What?
Tutorial. First, can you explain AQ 9.1 last question?
9.1 last question. This one.
Yes.
Okay, so in total we have 10 boys and 10 girls, right?
Yes.
My random variable x will take the value 2. Okay, but it's noting. If I have 2 girls, right?
Yes.
X is denoting number of girls. So x will take the value girl when we have 2 girls and 2 boys.
Yes.
So I need to choose 2 girls out of these 10 and 2 boys out of these 10.
Equal to 2 only girls, no? There is no boys. X equal to 2, X is only
No,
girls.
x equal to 2 means only 2 girls and remaining would be boys. I need, in total, I have to select the 4, right?
In the question, it's saying X is a random variable choosing only girls.
No, it's defined as the number of girls in chosen students. So suppose if I select all the 4 boys, in that case, X will be 0 because no girls in the chosen students.
Yes.
If I select 1 girl and 3 boys, in that case, X will be 1 because in the chosen 4 students, there is only 1 girl. Similarly,
Okay.
2 girls, 2 boys when X equals 2. So that's what X is. Number of girls in chosen students.
Sir,
Actually,
sir,
I
this
was
one, can you go through the...
Actually, I was thinking X is 2 means out of 4 students, 4 are girls. It's not like that because X is a random variable of girls.
Yeah. X is number of girls in the chosen students. So if I'm selecting 4 students and 2 are girls, 2 are boys, it means X equals 2. Right?
So the cardinality is nothing but 10C2 into 10C2.
Yeah.
Okay.
Sir, can you do the
9.4,
10th question?
question number 7. AQ 9.4, question number 7.
Someone was saying in this question.
10th one, sir, in this activity. So it's fine, sir, or later.
This one?
Yeah, 10th and 7th one I did not get, sir. I got 0.18 for this, but the answer is 0.3.
Okay, how did you approach?
Sir, yeah,
It's
so we can
0.18 into 2. Answer.
So we can take 9 and J, 9 and Q, 9 and K for that is 6 combinations. Then we can take 9 and 10 for 2 combinations. So total 8 combinations. Sorry, I'm
okay, let me just see. In total, there are 52 cards, right?
Yes, sir.
Out of which 12 are face cards and 42 non-face cards, right?
Yes, sir.
I have to choose any two cards of these 52, which I can do in 52 C2 ways, right? If I
Yes,
have
sir.
to choose any two cards of this, right? Now, if I have to choose exactly one face card and exactly one face card means I can do it in 12C1 ways. And the second card should be from this others category, right? Only
Okay,
then
we
I
can
can
directly 12 by 52 instead.
12 by 52 into 40 by
11.
51.
Yeah.
In that case, it is also possible that I get this over here and this over here.
Okay, so I took it only once. Sir, why are we doing this? Because it doesn't matter when we get the face card, right?
See, we are drawing one after the other. It's mentioned we are not drawing we are doing simultaneously as well, but it's mentioned that we are doing one after the other without replacement.
Okay, so that is a keyword for order matters. Okay.
Yeah. So if you notice here, if I draw face card first, right, then the probability of non-face card is 40 by 52. But if I am drawing non-face card first, its probability is 40 by 52. There is a difference in probabilities as well. Which one is you drawing first?
Okay, got it. Sir, and 10th question.
10th question. Okay. See, I have three adjacent houses, right? A, B, and C, right? And you have three letters for house A, for house B, and house C, right? If you get any of these two correct, suppose I got A correct and C correct,
The third
then
one is
automatically correct, right? It has no other way. So I cannot get only two houses correct. I will get either 0 or 1 or all three. There is no way I can get two corrects. So it's zero ways of getting that correct.
Okay, thank you very much, sir.
Something 9.4.
9.4, question number 7.
Question number 7. Okay. If shipment of 3 defective computer. Okay. Probability mass function of number of defectives. Okay. So here your random variable x is number of defectives.
Yes.
So I could get either none of the defectives, right? Or one defective or both of them defective. Right?
Yes.
In total, you have 20 computers. You can choose any two randomly in 20C2 ways.
Yes, that is clear.
Clear?
Yes.
So what are the ways that you get 0 defective? Out of these 20, 3 are defective and 17 are non-defective, right?
Yes, 3 are defective.
So I should choose both of the two computers from this non-defective.
Yes.
So it should be 17C2 and total number
Here,
of bases.
instead of doing all these calculations, by looking at the multiple choices, can I judge? That was my doubt.
By looking at the multiple, no, you have to compute at least two values. One thing you can compute is x equals 2. If it's 3 by 190, then your second option gets eliminated, straightforward, right?
Yeah, that's what. Actually, here these two options only satisfies first and second. So can I eliminate the second one by looking at the first one, like 3 by 190? How to confirm 3 by 190?
Or you can find x equals 1. It will eliminate. Yeah, x equals to 1 can give you the direct answer. Either it's 41 by 90, 68. Yeah, for x equals 1, if you get 51 by 190, you will left with only first and third options, which you can verify by computing
For
x
two defective pieces, how it, yeah, can you please calculate and show me once again, please?
Yeah, for two defectives, I select both of these two from this That would be 3 over 19.
Okay, clear. Okay, clear.
3 by 190. So I got this. Then I can, I can eliminate the second option. I'm left with only 3. Within these 3,
because I just calculated px equals to 1. Just I checked and I looked at the last option and I selected that one.
Okay.
First one. 3 by 190.
Okay. Yeah.
9.5, question number 3. This is last.
9.5. Okay, this
last
one also.
Is it discussed?
So what does this do?
Yeah, we were discussing. Okay, here you can see x can take values 0, 1, 2, and 3, right?
Yes.
So in such questions, always focus on any either 0 or the maximum value.
I get to get 50 million shutdowns.
Focus on any one of it. Okay. Suppose I take x equals 0. It is given to me as 0.027, right?
Yes.
X equals to 0 means I got no heads. I got no tails. I got all 3 as
No
heads.
tails. Yes, no tails.
So, okay, so since coin is unfair, let's say let probability of getting head is P. So getting 3
Yes.
heads, it would be P times P times P.
But the coin is unfair, so the probability of heads and tails, how it matches if we toss next time?
That wouldn't be the same. That's why I'm assuming that it's P. And probability of tails would be 1 minus P. Right?
Okay.
So that's P cube equals 0.027. So P equals 0.3. Another way to look at it is I take x equals 3.
Okay.
X equals 3 means I got all the 3 tails.
Yes.
Now let us assume that probability of tails is P. So I should get all the 3 tails. So P cube is equals to 0.343. So probability of getting tails is 0.7. So probability of heads would be 1 minus P, right? You can approach and so always focus on any one of it. Ignore the middle one values. It will make calculation difficult. Nothing else.
Okay. And this tutorial 2 is not clear for me.
The tutorial 2 also.
Is it explained in this session?
Yeah, we have done it. I think the question is this, right?
Yes, sir.
Yes.
Okay. So you know the properties of PMF. The
Yes.
first property is that all values should be
Greater than equal to 0.
Yes.
It means that alpha times P ratio to the power x should be greater than equal to 0.
Yes.
When is this thing possible? It is possible in 2 ways. First way is I have alpha is greater than equal to 0
Yes.
and P is greater than equal to 0.
Yes.
Or I could have both negative.
Yes, true.
But what would happen is suppose x equals 2. Okay. Then alpha is negative. P is also negative. So negative squared becomes positive. So negative times positive is negative. So your this case gets cancelled. It is not possible to have. So you are left with only this. Okay. Next property of PMF is all of them should add to 1. Right?
Yes.
Yeah.
Yes.
So if you plug in the values, it would be alpha P square, so on, up to infinity at 1. So if you know the sum of, have you gone through the tutorial of infinite sum series?
Yes. A plus AP, that is, yes, if A is less than 1, R is less than 1, it will converge.
So alpha
Alpha
1 minus p equals
1
1.
minus 1, yes.
So we get alpha plus p equals 1. If you cross multiply it. So here also see, if I have alpha equals 0, then all of my these value will be 0. It cannot add up to 1.
Yes.
So alpha cannot be 0.
Okay.
So for it to be valid PMF, your alpha should be greater than 0, p should be greater than equal to 0, and the sum of 2 should be 1.
Okay.
I think p should also.
9.5 third question, sir. 9.5
This one is clear,
third.
right?
Yeah, sir.
Yes, sir. I have just one more doubt, last one. There is no question, just doubt. In one of the option, it's given area under the curve of CDF is always 1. I mean, it's nothing related. I think nothing mentioned in the lecture related to
That's
this,
for
right?
continuous distribution. Yeah, it's not it. Earlier
Is
we
it
used to
area
have
related
continuous.
under the curve is 1 for continuous distribution?
Yeah, a continuous distribution used to be in the stats 1 syllabus earlier, but now it's removed. So that's why.
So that
No, we
question is
have
not.
continuous. Okay.
We used to have, but we have shifted it to stats 2 now.
Okay, so
But the
now
option is marked it as a wrong only. Choose the wrong answers. In that option is there.
Yeah.
Yeah.
That option is there, yeah.
Yeah.
Also, okay. So
Sir,
for the CD.
9.5 third one, sir, right?
Okay, thank you so much, Ishan. Thank you.
Yeah, that's what we also did. Okay. See here, it's number of tails, right? In 3 tosses. So in such questions, focus only on the value 0 or the maximum value which can ever happen. Okay. Focus only on one of this, not all of these. It will make calculation a bit difficult. Suppose I focus on x equals 0. The probability is given to us as 0.027, right? So x equals 0 means I got no tails. No tails means I got all of 3 assets. Is it clear?
Yeah, sir. Yeah.
Okay. Now I assume that probability of heads is p. So getting heads at all the 3 places, it would be p times p times p, right? Which is nothing but p cube, the probability of getting all the 3 heads. And it is given to me as 0.027. So p equals 0.3. That's what the
Sir,
question is.
but what it mean actually unfair coin?
Unfair means probability of heads is not same as probability of tails. If it is fair, then probability of heads equals probability of tails equals 0.5.
Sir, even this, if they didn't given fair or unfair, I used to solve in the left side, whatever the solution I might arrive. But thing they told that it is unfair coin, I thought something.
Unfair means it's not 0.5. Yeah, that's it.
Sir, even if it's unfair, so this
Yeah.
multiplication rule and summation rule, all this are like valid?
Yeah, you can define 3 events, right? Getting heads at first toss.
So the intersection of all these will always be a multiplication, even if it is a unfair.
Yeah, you can apply the multiplication rule. I think all these 3 events will be independent because you are tossing the same coin thrice. So whenever we toss the same coins multiple times, all the tosses are independent.
Okay.
Okay, so you can define 3 events like this. Right? E3 will be getting head at third, and then this will become E1 intersection E2, E3, right? And since all these 3 are independent, you can simply do it.
Okay.
That's p cube again, and you can solve like that.
Sir, a 9.661 also.
9.6, right?
Yeah, sir. 9.6, sixth question.
Find the probability that there are at least 2 defective items. At least 2 means I should get either 2 or 3. Have you converted it to the PMF? You know how to convert it to PMF?
नहीं सर बताइए.
So this thing is given to you, right? It's 0 if x less than 0, right? It's 0.41. It's 0 less than equals x less than 1, right? Next is 0.78, 0.91.
And 1.
Okay, so you know how we get these values, like how to get. This is the CDF, right? You know how can we convert it to PMF? So see, the first value is less than equal to 0.
Minusing before value we require to minus that one.
Yeah. So if you convert it to PMF, you notice your x takes value 0, 1, 2, and 3, right?
Yeah.
So x takes the value with probability 0.41, right? When x is in this region, right?
Yeah.
In this region means we got either 0 defective and 1 defective. It is given to us as 0.78, and we know for 0 defective it's 0.41. So for 1 defective it would be 0.78 minus 0.41, 0.37, right?
Yeah.
Similarly, for the third one, it would be 0.13 and 0.09 over here, right? You need to find that you have at least 2 defectives, which means you get either 2 defectives or 3 defectives, right?
Yeah.
So x equal to 2 is 0.13 and x equals 3 is.
Thank you.
Sir, activity question 9.1, 2 and 3, sir.
9.1. Arrange. Okay. Number of tosses until first head comes, right?
Yes.
So I could get head in the first toss, head in the second, head in the third, in the fourth, and so on, right?
Yes.
So my y can take all the values 1, 2, 3 up to infinity.
Okay.
That's what it means. Range of a random variable is set of all possible values that it can take.
Okay.
So if it's the number of toss until first head, it can take value 1, 2, 3, and so on.
Okay. Okay.
Third question.
Yes, sir.
2 cards are drawing simultaneously. As we define the sum of the point, sum. Okay. It's the sum. Okay. So if you know the cards, I have card like ace, then 2, 3, 4, 5, 6, 7, 8, 9, 10, right?
Yes.
And then king, queen, jack, right?
Okay.
So if you notice that weightage is given like 1, 2, this is the weightage points.
Yes, correct.
4, 5, 6, 7, 8, and then 10 for all of them, right?
Yes.
10 for 8, 10 for 8, 10 for these are the points you can get.
Okay.
So the minimum sum you can get is when you get 2 cards of weightage 1.
Yes.
That's your minimum value.
So that's why it starts from 2. Okay. Okay.
Yeah. And
And the
maximum
maximum
is
would be 10 plus 10. Okay, sir. Okay.
okay. Anything else? Anyone? Or shall we close for today?
So fourth question is discussed in activity 9.1.
Both second and third question, right?
Fourth, so second and third I asked you now. Or fourth question. How many
fourth.
outcomes will result in?
Sir, practice assignment 9, the last question, 7th question.
So the sum should be 19, right?
Okay.
We could get the sum 19 if I get one card of 10 points and one card of 9 points.
Okay.
Okay. So for 9 points, you have 4 cards: 9 of diamond, 9 of club,
Okay.
9 of heart, and 9 of spade, right?
Okay.
These are the 4 cards. For 10 pointers, you have king, and within king, you have 4: king of diamond, club, heart, and spade. 4, right?
Yes.
Then for queen also, you have 10 points. 4. Then for jack also 4. And then for 10 numbered card,
10. Okay.
you have 16 cards over here. So if you get one card from this and one card from this, right?
Yes.
Then you will get 19 points.
Right.
So one from these 16 will be
16 C1. Okay.
that's one.
Okay. Okay, sir. Thank you.
Okay. So I'm saying practice assignment, right?
Yeah, practice assignment, last question.
This one, right?
Yeah.
Were you there when I was explaining the total number of ways to play?
No, actually, sorry. I went out.
Okay. See, in how many ways I can play my innings, right? See, only possibilities are I could get either 0, 2, 4, 6, and 8, right?
Yeah.
So in total ways in which I can play my inning.
5.
No, not 5. It's like
Oh,
I
okay.
get out in the first chance. It is possible that I get out in the second chance, right?
Yeah.
I can get out in the third chance, then out in the fourth.
Add up all these cases.
Yeah. Out in the fifth. These are all disjoint events, right? And these are all my possibilities.
Yeah.
I remain not out. So number of ways in which I can get out in first chance. If I get 0, I could get 0 in only one way, right?
Yeah.
Out in second chance means I should get any of these phone number in my first chance.
Yes.
Any of these 4. And then 0 in my second chance, which I can get in one way.
Sorry, I didn't understand why you got 1 there.
Because I need to get out in the second chance. For that, I need 0 in my second chance, which I can get in only one way.
Okay, so the other 4 numbers in 4 ways. Okay.
Yeah. To get out in the third chance, I should get any of the 4 in my first chance. Again, any of the 4 in my second chance. And then 0 in my first chance. So that's 4 square. Similarly, it would be 4 cube.
4 cube, 4, 4, 4, 5.
So total number of ways one can play is.
Okay. Okay, sir.
Okay, that's 1, 3, 6, 5. And now you have to find that he will score more than 6 runs. Right? So probability more than 6 runs. I can take it as 1 minus probability less than equal to 6 runs, right?
Yeah.
So what all are the cases? I get 0 and get it's less than 6, right?
Yeah.
Less than equal to 6. First case. Second case,
2.
I get 2 and then out. Third is I got 2, 2 and then out. I got 2, 2 2 and then out.
Yeah, that's it.
If I do 2 4 times, then I would get more than 6, right?
Yeah.
Fifth case would be I got 4, then out. It's also less than 6, right? Sixth would be I got 6 and out, right?
Okay.
One way I can get 2 and 4 and then out.
Yeah.
4, 2 and then out. And there is no other way I can get less than or equal to 6 runs.
Yeah.
So there are only 8 ways to get this, right?
Okay. Yeah.
So the probability will be 8 by 1365.
So 1 minus 8 by 1365.
Yeah.
Okay. Okay.
Okay. Yeah. Anyone, anything else?
Sir, 9.1 question number 6, please.
0.1. This one, right? Number of.
Right. Yes, sir.
Okay, what is the answer you got? You got this as the answer? This.
-3, -1, 1 and 3.
Yeah, who asked the doubt? Like, how did you approach this question?
Yeah, sir, I'm not able to understand, sir.
So 8 cases, head, tail, head. You just have to minus them and see the values. You will get only -3, 1, 3 and -3.
This is your sample spaces. You can get these 8 outcomes, right? Head, tail, tail. Tail, head, tail. Tail, tail, head. All heads, right? And fifth one would be these are the all 8 outcomes you can get when you toss 3 coins, right?
Yes, sir.
In this, number of heads and number of tails. And X is the difference of these, right? So number of head is 1, number of tails is 2, right? Here 3 heads, 0. These are the values, right? For number of head and number of tails.
Yes,
now
sir.
I need to find the difference. So 1 minus 2 is -1. 3 minus 0 is 3. 2 minus 1 is 1. And -3. So you see the distinct value which we got is -1, -3, 1, and 3, right? These are the 4 possible values that X can take.
Okay, sir. Thank you.
Okay. Anything else?
That's it, sir.
No, sir.
Okay.
Done.
Okay. Thank you, everyone.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Yes,
Thank you
sir.
very much.
Thank you, sir.